GUI. In this section, we'll go over the process of configuring Y.RIS using the GUI. Please make sure that you have installed MATLAB or MATLAB Runtime version 9.12 on your computer before we proceed. To begin, choose the Release folder. Open Y.RIS GUI version 1 and open Y.TTEK Y.RIS version 1. You will see the GUI interface and an executable window. Clicking the Initialization button in the GUI prepares YTPC to operate Y.RIS in the MATLAB environment. When the executable window displays Initial completed, it indicates a successful initialization. Basic functions. After initializing the system successfully, we can proceed to introduce the functions of the four adjacent buttons. The Load button is used to load previously saved configurations. The Save button is used to save the current system configuration. The Send button is used to transmit the current configurations to the Y.RIS system. Lastly, the Reset button is used to cancel all the current settings. Choose Mode. Next, we will introduce these four modes, categorized based on distance: P to D, P to P, D to P, and D to D. Here P stands for point, and D for direction. The distance refers to the distance from the antenna to the center of Y.RIS, as illustrated in the image. Based on the formula displayed in the image, we can distinguish whether the current distance is in the near field or far field. If the distance is less than the calculated value from the formula, it's classified as the near field, which corresponds to the point. On the other hand, if the distance is more than the calculated value, it falls under the far field, which corresponds to the direction. After selecting the mode, the next step is to configure the parameters for TX and RX. It's important to note that the required parameters vary depending on the mode. In the point mode, input values for X, Y, and Z. These three values represent the antenna coordinates with the center of Y.RIS as the origin. As illustrated in the bottom left image of the GUI, the positive X direction faces to the right of Y.RIS. The positive Y direction is vertically upward facing Y.RIS. And the positive Z direction is the normal direction of the LC panel. In the direction mode, input values for theta and phi. The two parameters represent the spherical coordinates with the center of Y.RIS as the origin. Theta represents the polar angle between the z-axis and the radial line, and phi represents the azimuthal angle between the x-axis and the projection of the radial line onto the xy plane. D to D demonstration. After introducing the functionality and parameter settings of the GUI, we will proceed with a demonstration. We will use case 4 as our demonstration. For the TX parameters, we set the theta angle to 45 degrees and the phi angle to 0 degrees. For RX, we set the theta to -45 degrees and the phi remains 0 degrees. After configuration, you can view the predicted radiation pattern and phase distribution in the GUI interface. Finally, click the Send button to transmit the settings to Y.RIS. In this scenario, the actual radiation pattern matches the predicted one on the GUI. We observe an EVM of approximately -26.5 dB. At this point, when we change the angle of the RX antenna, we can immediately see a degradation in EVM performance. This is because the RX antenna is pointing away from the beam direction of Y.RIS. Now, returning to the GUI and readjusting the RX angle, the EVM improves to -24.7 dB. From the results, it is evident that by inputting the correct parameters into the GUI for Y.RIS, it can dynamically adjust the phase of its individual elements, effectively focusing the signals toward the desired location.